Hello, my name is Paweł Marks. Currently, I am leading Scala free compiler team here at Virtus Lab in Krakow. You may better know me as a guy responsible for Scala compiler releases. You may encounter my name in release notes for new version of Scala, or blog posts about binary compatibility, or our long-term plans for Scala support. But today, I'm not here to talk about our compatibility guarantees, but actually about one feature of Scala, context functions. So context functions are with us since Scala 3.0. It is over a year and a half since they premiered, and in this time there was a lot of great talks, tutorials, explanations, blog posts detailing everything about them. So I can assume that most of the wider Scala community is well aware of them and understands them. But even though I decided to do that talk, to apply this conference, because I believe in my research about the usability of context functions, I ventured further and deeper than anyone before me. And I want to show you what I found. But this will be on the later half of the talk. Because the first half of the talk, to keep your attention, because the first half will be rather simple, introduction to context methods, so we all can be on the same page. I've got a little brain teaser for you. Let me show you this snippet of code. Our intuition is that no matter what the type X is, this snippet should compile. We have a method that is returning X, no matter the implementation. We are assigning this method to some value. The type inferred here should be X, and then we are assigning this value to other value. And here we explicitly write in type X. Nothing to not compile here. It's compiling for strings. We can even have some generic type here, like list of string. It will always compile. But what if I tell you that there is one type, one very simple type? You can define it in single line, quite short line, without using any advanced mechanisms of the language. And this type will make this code, let's call it Mystic, actually not compile. It's even funnier, because when we add another short line on the top level here, we can make not only this code compile, but even this code compile, and also pass type checking. You will see what I am talking about later when I got there. But let's start with the basics. So, what is context in context functions? Or even better, what is context? You may have realized or not that since the beginning of this talk, I've not even once used the words like programming, programming language, computer, even though you understand that I am talking about Scala, the programming language that can run programs on computers, because you know context. And this is what the context is. It is normal in conversation between humans that we are not specifying to our partner in conversation all the information they need. We can assume that they can infer some information because they have some previous knowledge, they understand some context. Programming languages, however, are not exactly like that. Most of programming languages need to be told everything they need to know to execute the program. But Scala sometimes is slightly different. We can, for example, in Scala 3, summon some programming knowledge just as it was parameter that was passed to our function, and we can use this value, even this value was not specified by us anywhere. And we can do that inside a function that is not taking any programming knowledge as a parameter. But this is not as simple as that. Such as in real life, there are some limitations. In real life, when I would talk exactly the same words I am talking right now to you, to some random person on the street, and even show them the same slide I am showing you right now, there is a good chance that they will not understand even the word from what I was saying, and it would be not beneficial for them. This is because they are lacking context. So I cannot assume that everything has a context to understand what I am talking about, and the same is true for Scala. You cannot just summon this from any scope. You need to have a scope that is aware of this context. So in this example, we have a function that we are saying is using programming knowledge. So we can say that your mind knows the context of programming knowledge. But we are trading off specifying types explicitly to specifying them without the name. So what's the benefit of this context? Basically, the simplest benefit is here when we have a whole family of functions require the same context. Then we can call one of them from the other without passing any arguments explicitly. So, for example, here we have function doScala that requires programming knowledge, and we know that your mind also is requiring programming knowledge, so we can easily call doScala from your mind, and it will work. We don't need to care about passing programming knowledge down. Someone else will provide it somewhere in our software. But this is something that was already available in Scala too. You just swapped using for implicits and add name to them, and you can do exactly the same. But there was important difference. In Scala 2, there is no way to express this notion of context in the type system. What do I mean by that? If we have this function doScala requiring programming knowledge, here shortened just to PK in its context, we want to assign it to some operation that we can pass around and finally run in the place when it can have this context. But we cannot actually do that. This is a compilation error because we don't have any type that we can put here. We can do some tricks, like, for example, transforming this function that requires some context into ordinary lambda, but then what we get is function type. The information about the programming knowledge was meant to be passed as a context was actually lost. We have ordinary function. So Scala 2 type system didn't care at all about contexts. Okay, but what is the situation in Scala 3? Here, we can do that assignment. We have a special type that looks nearly exactly the same as function type, but it has this question mark inside of it, and it reads that it is something that returns unit, but requires programming knowledge in the context. So this is what we call context function type. And we don't need any longer any conversion of this function into lambda for it to work. It just works. Okay, so what now can we do with these context functions? We can just, if we have operation that has type of context function, we can just running inside of other function that is providing this context, either like this, or it can be defined like this as another context function, or even it can be just a value. In every of these places, we are sure that operation will actually get its context, needed context. Cool. So the other thing we can do, we can invoke it inside of ordinary function, but we need to be careful and be sure that somewhere in some enclosing scope, we have defined given instance that can be used in this context. So in this example, in the same function, we are defining given instance for programming knowledge. Cool. We can even manually create this instance and pass it manually using clause on the invocation. It will also work. Okay, so I showed you what you can do with context function types, but all of what I showed you for now is quite boring. It is not interesting. When the fun begins is when we have context function type on the parameter of the function. So something like this. This function work is accepting block of code. Inside of this block of code, we know we have programming knowledge in the context, and this block should return unit. So we can pass block of code like this. We have a functions find problem, think about, and write code, and we can assume that all of them requires programming knowledge. We are running them inside of block that we pass to function work, so we are sure that we have context that we need here. The implementer of method work will need to provide it somehow to execute our block. If we remove this invocation, this won't compile. We cannot run this function outside of work. So we may say that the compiler cares about our work-life balance, not allowing us to do coding outside of work. But we are developer, we are clever, it is not easy to stop us from coding, so we can manually define our own given instance of programming knowledge, and this code compiles again. But if someone has a control over the programming knowledge definition, for example, our company, they can define it like this. So this class programming knowledge has private constructor, private in the company package, so it cannot be instantiated outside of it. So if we want to use something that requires programming knowledge in its context, we need to use tools that they are providing us. So we need to run it, for example, inside of work block. So in other words, programming knowledge can only be used inside of company. And the compiler will enforce that. Okay, so with knowing this restriction, everything we talked about sounds like DSLs. And context functions are excellent tool for writing custom DSLs. I mean here domain-specific languages. So let me show you some example of DSL defined using context functions. Let's imagine that our domain is quite simple. We need to design a language that will just create a table. The table can have multiple rows, and each of these rows can have multiple cells. Of course, this DSL that we are designing here will be overkill, but I want to show you a few mechanisms. So let's start with something that can create a table. Function table will do that. It returns something of type table and accepts multiple rows as a parameter. What's this inside of this definition? It's a var that is accepting context function from tctx, let's call it table context, to row. So basically something that creates row and can be invoked in table context. And we have a function for creating rows called row that, as we can see, is using table context. So it can only be run in places when something is provided table context. So for example, inside of this table, parameters of this table function. It also, we can see the same trick as we before with rows, this time with cells. So it accepts a list of cells, but they are not just cells. They are cells that can be created in row context, RCTX. And we have our function for creating cell. It returns cell, it don't have any children, it only displays some text, and it can only be run in the row context. So how this DSL looks in action? Actually like this. We are creating a table. This table has 2 rows. Each of these 2 rows has 2 cells, and it's compiled and it is looking quite nice. Okay. So we maybe try to break it. Let's remove the second row and try to insert the cells straight into the table. Will it work? Will it compile? Let's see. So the cell function to be invoked requires us to provide row context, RCTX. But we are running it not inside of row function, parameters of row function, but inside of table function. But this table function is providing us with table context, tctx. So we don't have an instance of row context. So this is a compilation error. Compiler will complain, this code will not compile, we need to fix it. Okay, let's break it another way. Let's do nested rows. Will this compile? Let's see. Okay, so the method row is returning instance of row, easy. But We are calling it inside of another row method, and it expects that we will be passing cells, not rows. So generally speaking, there is a type mismatch here, and this code will also not compile. Okay, so we've got our simple DSL. Of course, we can go much further with that, introduced more advanced topic here related to DSLs. And I think this is the direction that most of the explanations of context function will go into. But they will talk about pros and cons of different styles of DSL, about mutable builders, immutable builders, etc. But I think there is already great amount of really good resources in the internet about that. So I will not go here into any details because I want something more. I want to answer a question. Can I build entire business application only around context functions? You may ask me why I want to build entire business application around context function. And to answer you that, I will show you how I often imagine bigger application. I really imagine them as compositions of smaller tasks, and each of these tasks have its own input, output, and context. What do I mean by this tree? Let's look at the simple example. Let's take what is the simplest possible task. For example, taking user data from the database that we know ID of this user. So this operation is quite simple, self-contained task, but it has known input, ID of the user. It has known output, the object representing user data. So let's call it user object. But having only user ID, we cannot just return user object. We actually need to get the data for it from somewhere, from the database. And to query the database, we need connection to the database. And most of the programming language are handling it the way that we pass connection to the database as the same way as we pass inputs. So for example, most of the programming language will see this task as we will see the inputs. We will see this task that it takes connection to the database and ID of the user and return user. This is this output. But for me, connection to database feels quite different because when this is a big application, I'm probably only doing a small part of it, some fragment, some piece of the bigger whole. So here I am not really caring about how to get a database connection, where it came from, how should I manage that. I only want to state that my task require connection to the database and larger application will provide with me. User ID is something different. I can manage it. This is directly connected to the domain I am working with. Okay, let's see another example. Here we, for example, have logging. To log some message, this is also a task that have this message as an input. It don't have any meaningful output, so we say that its output is unit because only is doing some activity, nothing more. But the logger itself is also a context. Why? Because in different environments, in different builds of our application, different deployments of it, there can be different loggers depending on the configuration. And we don't want to, as someone writing a simple task, we don't want to think about what logger will be provided, how we can get it. We only want to state that we need a logger and the instance will be provided for us. And this here we are touching the important subject of dependency injection. As I said, we don't want to manage instances of database connection or logger. We only want to state that we need them. We can expose that we are some task that requires them, and someone will provide it for us. And this kind of thinking is something that is widely adopted in modern frameworks, in Scala and not in Scala. For example, Zio. Zio is a library that handles not only that, but also stuff like asynchrony or error handling. But if we, for a moment, forget about those two, we see that all tasks in Zayo are really some transformations from the context that they call environment to some output. And also they have sophisticated mechanisms of Z layers that allows for dependency injections. I must admit I've never used in any real life Zio in any real life project, but on paper it looks brilliant and it looks like a great library. So yes, so this is way of thinking that is already present, even in Scala. But what if, just for curiosity, we try to achieve the same thing using mechanisms that are not from some framework, but are built into a language? So, can we do that? Context functions, or even broadly speaking, context abstractions, so given and usings, look like a perfect mechanisms because they can easily state that we need something and provide it without like our intervention. So you probably can guess what's the answer for this question because I applied for this conference, I standing there here before you. So can I build entire business application around context function? No, I cannot. You may ask me why. You may ask me that there are projects like that. You are working in one of such projects. Sorry, we have a problem, I think. Okay, sorry. Someone was showing that I have a technical problem. I'm really sorry. Okay, someone is saying for me that there are projects like this that are composed around context functions, that I am working in one of them. Here I mean Scala compiler. Inside of Scala compiler, 3/4 of all methods are signatures that have clause at the end using context. But this is not what I want to achieve. This context that we have in compiler, it fits for the compiler, but I don't think it fits any business application because this context is some godlike type encompassing all the context of entire execution. All information that we can have are in this context. And if we are building our business application with that, that will be bad. Not only we won't be able to track what services are needed in what parts of application. Moreover, we cannot really be sure if the entire context of entire application contains the service that we need right now. Moreover, I don't think that we really want every single small task to depend on information about the whole execution of the program. So what I want and what I think will be good if we can have the smallest possible context for each task that is requiring them. And I say that it is impossible, mainly for two reasons. First of them is lack of type inference. The second is lack of composability. So let me try some really simple real-world example, and I will tell you what I'm here saying about. So we've got three functions in our system. One is getting user, one is logging message, and the last one is getting some more info about the user from some external API. And they look really good. We have clear separation of input, context, and output. Get user takes ID of the user as an input. Then there is a context, so DB connection, and we are returning users. The same can be said about all of this method. So it looks pretty cool. So let's create our first task using them. So here we have our task. It also not looking bad. We are saying that it has context that it requires logger and database connection, and it returns user. Inside of it, we've got call to two of our methods, get user. This is the one that was requiring database connection, and we are logging information and returning users. It looks pretty cool. What can we do with that? So in real life, we'll probably have some submit function that accepts some operation and provides this operation with lots of services. So it will have logger, DB connection, and many more what it needs. And the entire submit function will return the return value of this method. Cool. So we can just run it, and this task will be provided everything it needs. It will work. We can also do it like this. Let's say we have some main methods. Inside of the methods, we'll manually define given instances of DB and logger and just run our task. It will work. But normally, we will not be invoking such simple tasks this way. We will compose like bigger operation from smaller tasks. This is normal way of creating applications, and then run these big applications. So we need some composing. So speaking about composing, let's see how it may look like. Okay, here we created the second task. It has some wider context. We've added external API to this context. And we are running our previous task and then running more info functions that needs this external API. It works like a charm. But there is first problem here. This type of this task is quite long, and we are no longer writing our code in Java 6. We are smarter than this, or at least we have a type inference. Or do we? This code actually doesn't compile. Fortunately, compiler error here is quite helpful. But if it wasn't so helpful, or we are actually new to this entire context function business, we may be confused. And we may start to minimize our code to see the moment in which it stops working. Okay, so minimizing it will end with something like this. And it will still doesn't compile. For any newcomer to the language, just assigning one value to the other seems like something that should always compile. So what's going on? You can see that I changed background to dark, so we are off for some long digression. Okay, let's imagine we are doing our investigation and we try to understand what's going on with types of context functions. We fire up REPL and we are typing this simple context functions. It takes two context parameters, A and B, and it returns R. And then we will start to assign it to all different kinds of stuff and see when it crashes and when it works. Okay, so first we are doing our zero hypothesis. So can we assign that to something that has exactly the same type? So we are creating value y with exactly the same type and assigning, and it compiles. And then we see we've made a mistake. These types are other way around. So we quickly correct our mistakes. It also, as expected, compiles. But wait, this example also was compiling. So what's going on? These are different types. You cannot just assign function to this function with arguments swapped. It doesn't make sense. Okay, so we are investigating further. So what about functions that can have three parameters? We are assigning, and it still works. Apparently, you can assign context functions taking two parameters to context functions taking three parameters. It's okay for the compiler. Oh, we can even carry that. So we are no longer having context function accepting A and B. We have context function from A to the context function from B to R. And we are assigning our original context function from A and B to R, and it's still compiling. We can swap these arguments around. It is still compiling. We can do some really crazy stuff like get intersection of both this type, and it's still compiling. Look here, we are assigning context function with two parameters to context function with only one parameter, and it's still compiling. What's going on for real? What are we, Python? Okay, so we're starting to question our sanity. So we do one last experiment. We just remove this question mark and live with ordinary function. And we suddenly have our sweet compiler error that we are waiting for. This code doesn't type check. You cannot just assign function with two parameters to function taking one parameter. So you backtrack and read all the examples that we have done, but this time not with context functions, but with ordinary functions. And all of them, except the most trivial one when the types were the same, are not compiling. So they are compilation error. But now we are thinking, why is compiler treating ordinary function and context function so differently? Why? If I were archaeologist, I would answer that compiler is doing that for ritual purposes. Because as you probably may have known, among archaeologists, when they say something was for ritual purposes, that means that they have no idea what was used for and how this object even get there. But we are here not archaeologists. We'll not be satisfied with the answer that compiler is doing something for ritual purposes. We will investigate that, what's going on, and how context functions are different from ordinary functions. Okay, so to understand that, we'll require two additional bits of information that may not be obvious for everyone using Scala in everyday life. First of them is that our intuition about the typer is that it takes simpler expressions, then combine them into bigger expression, and using the types of the simpler expression creates bigger type. So like one integer plus another integer is a bigger integer because there's operation plus between integers. But there is also, some people may not have known, compiler is also taking into account what is the expected type. So for example, if we are defining some value and we are ascribing type directly, we know compiler has knowledge what we expect this type to be, and it is using this information for transformations. The other part some people may not know is that the typer sometimes rewrite our code. This is something that allows for a lot of magic in Scala to actually work and to happen. But it may be not intuitive that during the typing process, our code ends up different than when we write it, but for the compiler, it's all the same. Okay, so this what I will be showing you is great simplification, but what compiler do in this case? It uses the information about this value y has expected type that is context function. So it rewrites our code. It creates a block. Inside of this block, it defines anonymous function that is taking two context parameters, and then it's returning this function. Okay, but what's the body of this function? It's easy. It's the right-hand side of this value. So in this example, x. But the compiler sees that x is not ordinary value. It is also a context function, so it needs to be expanded. This is the mechanisms that allowed context functions to catch any given instances from scopes surrounding them. So here, our x is expanded to application of this x, and parameters for a and b are summoned. So this works because the closest scope to this have both a and b, and everything is satisfied. The typer is satisfied, the code compiles. Let's do another example. Here we have y is context functions taking 3 parameters. So it is rewritten to anonymous functions taking these 3 parameters, and x is expanded, and we already have a and b inside of the scope, so everything works cool. But what happens in this example? We don't ascribe any type to y, so there will be no rewrites. There will be no block or context function created. We just have our right-hand side. So we expand it because we need to expand it for context functions to work. And then the compiler needs to infer type for y. So it says that x, if it has a and b applied, and it says that these parameters are applied, returns r. So the r is type of y. And it works perfectly well as long as there is some given instance of A and B in some of enclosing scopes. But it may be not the case. We maybe don't have these instances. So then this is the compilation error because the compiler cannot summon A or B. This, you may find it kind of strange, but in reality, this is what you are actually expecting. Normally, you would use that code when you have given instances of A and B inside your scope, and you are expecting it to work like that. Okay, but can we get around this property of context functions using type aliases? So let's define the type alias. Let's call it mystic. You know now where I am going with this. This is alias for context function from integer to some t. And we created value that has type mystic of string and try to assign it. But of course, it doesn't compile. The compiler is smart and it is aware that this mystic type is just a context function wearing a trench coat. But we can create given instance of integer, and this code suddenly compiles. Even better, we can just ascribe type string to the y, because this mystic after application returns string. So our mystery from the teaser solved. Okay, so we tried type aliases, but Scala 3 also have opaque type aliases that are not expanded by the compiler in the same way as ordinary type aliases. So maybe they can work. They seems to be perfect. Oh, it was 3 weeks ago. I am wondering if it has something to do that 3 weeks ago I was experimenting with opaque types over context functions and reported some issues about not behaving correctly. Yeah, it may be that. So sorry guys, this will not compile now. Okay, no longer black background. Let's end this digression and get back to our original question. Can I build entire business application around context functions? I've told you about lack of type inference and why type inference can never work with context functions, but there are also other reasons that I mentioned. So the context functions lack composability. It is really hard to show on such a simple examples that can fit into slide. It is really manifest when you try to create some bigger system. But even though if you try to extrapolate from this example, you can see that we are only using direct style. We don't have any mechanisms like higher order function. The for comprehension will not work with that. So we are forced to write everything like that. And many people don't like that because the code becomes kind of boilerplatey, less composable. And the reason for that is that I cannot even imagine any sound implementation of flat map or any other higher ordered function that will work for any context function. I don't think it's doable. So yes, another problem is that context functions are not really composable. Okay, so we probably answered our questions. We cannot solve this problem. We cannot build business applications around context functions using conventional measures. But what about unconventional measures? I am a stubborn guy. And also, I really wanted to learn some real-life hardcore metaprogramming, like hardcore macros, hardcore compile time reflection, and maybe I've achieved something. So enter macros. Oh, if I wanted to describe my entire journey and many rewrites that I've done and back to the drawing boards that I've done trying to prepare this small library I was talking about, this talk will last like 3 or 4 hours. There was so much of it. But finally, I'm at a point that I am quite sure I can share with you some really small library. Here is it's on GitHub. It's named lore because the context, because sometimes you need to understand the lore to know the context. And this library is really small. It's like 3 files, which one is really important. And it was result of many experiments, but what I achieved there is 2 macros. That allows us to pretty much work with context functions. I also want to warn you that this is really hot code. This is quick, early prototype. Probably it is bugged. It is not tested. It don't work for any edge cases. And the worst thing is if you encounter bug there, it is not some exception in the runtime. When you encounter bug them, it will crash your compiler during compilation. So you have been warned. But nevertheless, you can try it. You can have a look at GitHub. Of course, if you are sure that you want to know how hot dogs are made. Okay, so the macros that I created. This is the first one. Its declaration signature is kind of mouthful, so I'll take it apart for you now. This is def, so it is a function. It is inline def, which means this is function that is executed, expanded in this context during the compilation, not during the runtime. It is transparent inline def, which means this is function not only expanded during compilation, but during typer phase, so it can interfere with typing. It is named task. Okay, easy enough. It has 2 type parameters. You can guess that those are first letter of word, context, and result. And it accepts 1 parameter. This parameter is block of code, which is inline. That means that inside of this method, we will have knowledge about how exactly this block of code looks like. This will be really useful for us. And it accepts some context, accepts a context parameter, and returns some result. So in other words, it is context functions from C to R. Our return type is something that I will talk more about in a second, but you may be sure this is ordinary class, nothing magical here. Okay, so we can use our example from this few slides ago and pass it to this as a block of code to this task. Should it compile? You may realize right now that we are not ascribing any type, and this is because it causes type inference to actually work. But let's see if it's really compiling. So let's talk about the types. We can specify them explicitly. It is not needed normally, but we'll see what we have here. So first we look at result. This is quite simple because we are down on user using getUser method, then we are returning that. So our result is user. And what about the context? So as you know, if compiler expecting some context function type, it starts to rewriting our code. And it is doing this rewrite here. But it needs to know what exact type of C is. So it looks inside of body of these functions. And what it sees? It sees that we are actually require 2 things. The first of them is logger, and the second one is database connection. So you may think that it doesn't compile. We are required 1 thing, and we need to put 2 here there. But I show you today that you actually can assign a function that takes 2 context parameter to function that takes 1, if this 1 context parameter is intersection of this type. So actually, what will be inferred here by the compiler, we don't need to write that when we are using that, is DB connection and logger, intersection of DB connection and logger. And this is really scary looking type, but it's only to satisfy the typer. It will never be instantiated, we will never see any instance of it, it will never come to life. Okay, that means that the return type of this is user using DB and logger. What does it mean? So using is, as I said before, ordinary class. It takes 2 type parameters, and this, so it can be, the type can be instantiated like that. It is user using DB and logger because it can be written as infix, and by default it is displayed by the compiler as infix. And I really prefer to use parentheses here, so we have really clear separation about what is the output and what is the context here. Okay, so we have our type. And as I said before, this is ordinary class, nothing magical here except how we get into that class, how we are creating instances. So everything works perfectly with type inference. So yes, so what we can do with that? Oh, there is another macro. This macro is called run. Actually, I cannot show you much because this method, the signature of this method cannot be really expressed in Scala. This method needs to be generated by macro. And this method run, actually, it's just plain context function. In this example, when we have something that's context was db intersected with logger, here we have something that requires db and logger in its context and return users. And you might notice this is ordinary two-parameter context function, not fancy intersection or anything like that. This intersection type was only to satisfy the typer. We'll never be invoking them. And as you can see here, we are just running in a context that we have plain db and plain logger, and it will work. Okay, so this using has few other benefits. For example, it is, as you may notice slide before, it is contravariant in its context type. So it means in practice that we have some task that runs in some context. We can assign this task to the other task that runs in wider context. This is quite intuitive. If I can do something in one context, I can also do the same in contexts that have all the elements that my context and also some other. I will just ignore the other elements. And also the context type is expressed as intersection type, and so we can freely swap the order of elements in the context type. This will be always interpreted by the compiler as the same type. Okay, so what about the composability? Because I've shown you that we solved the problem of inferability, we can infer that. But what about composability? As I said, this is ordinary class, so there is nothing preventing us from defining flat map over this. Actually, its runtime implementation is really tricky, but you can do it like that. You can have flat map that is accepting operations from your return type to some new using object, and it returns combined flattened using objects. You can also define more and other context and other higher order functions like that. But these flat maps will give you access to using this type in for comprehensions. So yeah, so I think composability is also solvable. Okay, so let's sum this up, what I showed you. So I believe that context function and more generally speaking, context abstractions, so givens and usings are the great mechanisms for tracking of environment or tracking of context and for dependency injection. And they are great because they are built into language. They are independent from framework that you're using. You will always have them. And someone who is using different framework will also have them. They, however, have few shortcomings. First of them is they are not good in terms of type inference, but using some clever metaprogramming, these problems can be solved, what I shown. And also they have problems with composability, but also I showed that using some thin wrappers, we can also solve that problems. So what's next? I've got this prototype of the library that I showed you before. And it's really, as I said, it is really a start of the work. It is really a prototype. It is not something that is really usable. It just worked for some examples. So I will probably just now, if I have a free time from my other responsibilities, I will just put some work in this topic. And probably there will be some outcome. This outcome may be that in a 2 or 3 week, I will see some very eloquent blog post explaining why my approach doesn't make any sense and why it is unsound and it's harming ecosystem or anything like that. And maybe they will be right. Maybe I, working on this, will encounter some unmitigable problem that I will not be able to solve, and I will just drop the projects. Or maybe we'll meet in a year time, and I will be saying to you that, yeah, I am now sure that this is the production-ready solution, that if you are starting a new project, we've got something that allows you to really simple dependency injection or environment tracking, and you should use that. Or maybe some mainstream framework will adapt some elements of my idea and merge it into it. Maybe, I don't know, we'll see. But what I most hope is that I gave some of you some idea about experimenting, about trying something new, and most importantly, I hope that you enjoyed this talk. Thank you.
Hey, thanks so much for your talk today. I have a question. Just 1 second, and we'll get that up on screen for you. Okay. Would future INT using DB or similar types work for the 4 comprehensions?
So this is classic problem of monad transformers. These are basically nested monads. So I have no idea. As I said, right now, the using is ordinary type. It is not something special. What is important to note here is that I don't make any changes to the compiler. This is right now the nightly build of the compiler I'm using for this. So this is ordinary type. So you will have exactly the same problems as you have with nested monads, but probably in the future we can either merge it with some monads. So for example, the approach that Zio did that merged either one monad IO for asynchronicity, and I don't remember right now, but basically there are 3 monads into one. Probably someone can correct me in the comments if I mess something up. But yeah, but probably you can either merge it with futures. That's a good idea. Or just write some monad transformer. We will see. As I said, this is only a prototype. We will see where it gets us.
That's great. Well, best of luck on making it happen outside of the prototype. And I don't see any other questions at this time, but really, thank you for being here. Thank you for your presentation, and I hope you get to enjoy the remaining talks of the conference.
Thank you, and yeah, I will enjoy. Bye.
Great.
Fire in retro rock.
Roger, Matt. Ready to eject.